Hello, everybody. Welcome to AMS Weather Band's latest webinar, Making Snow Mistake or Make Snow Mistakes, rather, Tips for Measuring Winter Precipitation with Steve Hilberg, Noah Newman, and moderated by Melissa Griffin. Now, before we begin, if you haven't been to any one of our webinars before, I would like to address some more guidelines for the webinar. If you have any questions during the course of the presentation, please put them in the Q&A option that you will find on the bottom of your webinar screen. We're going to try to shepherd all of the questions in there so that we don't have to sort through everything in chat to find the questions that we want to address. If you want to say something in chat, you can put it there, but the questions, the Q&A, that's where they go. We'll also have some specific time for questions from the audience after the precipitation. Yes, weather band. After the presentation, but they may also be answered during the course of the presentation, depending on the flow of the program. Now, before we get started, I would like to introduce today's moderator. Melissa Griffin currently serves as the Assistant State Climatologist at the South Carolina State Climatology Office. Melissa received a degree in meteorology from Florida State University and has worked in the weather and climate enterprise for the past 2 decades. Melissa is also involved in various weather-related outreach and education initiatives, including the Community Collaborative Rain, Hail, and Snow Network. With that said, I hand it over to you, Melissa. Thank you.
Thank you so much, Gideon, for that introduction. Thank you, everyone, for joining us this evening. I'm very excited that we have a great turnout to learn a little bit more about making snow mistakes when we're doing our wintertime precipitation measurements. And we're very lucky to have 2 members of CoCoRaHS join us tonight. We have first Steve Hilberg. He is the program manager for CoCoRaHS and oversees the data quality assurance and data quality control. He served as the Illinois state coordinator, and he's been an active observer since the program began in Illinois in December of 2006. He is the retired director of the Midwest Regional Climate Center. He served in that role for 13 years, and during his time, he was a co-developer of the Accumulated Winter Season Severity Index. You guys may have heard about that on TV. His background includes experience in applied climatology, operational meteorology, broadcast meteorology. He is a very big fan of snow and winter, and he'll take that any day over a tornado. So we're happy to have Steve join us. And we also have Noah Newman. He is the research coordinator for the Colorado Climate Center and also the education and outreach coordinator for CoCoRaHS. He has been a third generation native of Colorado. So Noah grew up with basically snow and water in his veins. He likes to ski in the winter, and he's been doing that since he was, 5 years old, I think, Noah? And in the summertime, he has been a whitewater rafting instructor. He received his bachelor's degree from Colorado State University in 1997 and began teaching informal science in 2002. He's experienced in teaching informal science and science education and astronomy and zoology. It just can't, all A through Z is basically what Noah's been able to do. He's led professional development training sessions for teachers, K through 12 classroom presentations. He's also, you may have recognized his face. He's done a couple appearances on the Weather Channel talking about snow and CoCoRaHS. And he continues to lead these classes and webinars. So if we do have any educators who are on our webinar today, you can always get in touch with Noah and he can talk to you about CoCoRaHS in your classroom virtually. So with that, I am going to turn it on to these very informative, as I like to call them, cuckoo for CoCoRaHS, just like me, and learn a little bit more about snow observations and the importance of making accurate snow observations. So with that, Steve, I turn it over to you.
Thank you very much, Melissa. And we are very happy to be here tonight with the AMS Weather Band. This presentation will be sort of an abbreviated, there'll be some background, but there'll be an abbreviated portion of our actual snow measurement training. That could go on for a little bit longer than the time we have here. So we'll give you some information on how you can access that separately from this webinar. So thanks again for having us. I guess we're going to start out with a little background on snow measurements. I like to call it that snow measurements have had a checkered history here in the U.S. at best. And you'd actually be surprised when we finally sort of, what you might say, got our act together on snow measurements. All right. So that way back in the 19th century, in the 1800s, Cleveland Abbey was a very renowned and prominent meteorologist of the time. He recognized all the difficulties and problems you could have measuring snow. And that was something at that time, but it seemed that people didn't pay a whole lot of attention. He pointed out that rain gauges tend to perform poorly in light, dry snow and or high winds. And we know that very well if you've ever taken a snowfall measurement. Also, a true measurement of the precipitation should be made by taking a core of new snow, then melting and measuring that amount. That is called the snow water equivalent. That gives you, in most cases, and I'll say most cases, it's not perfect. It gives you a more accurate representation of the precipitation that fell than a regular rain gauge, 8-inch or 4-inch. And then the measurement of water should not be done using a ratio of 10 inches of snow to 1 inch of water, because he said the wide variability of this ratio for different kinds of snow. And we know that now, but yet there are people that still use that. The total depth of snow on the ground, what we in CoCoRaHS call snowpack, should be a part of every observation. So he's talking about 3 separate things here, actually 4. The precipitation from the gauge, measurement of snow on the ground, the new snowfall, the measurement using a core of snow, or the SWE, and then, of course, the total depth of snow on the ground. And we'll talk about the importance of all these a little bit later on. So Cleveland Abbey was really on top of things way back in the 1800s. Unfortunately, the rest of the meteorological world wasn't quite as on top of it as you might think. There have been a lot of variations of how snow has been measured. In fact, early in my career, when I was helping out with a co-op station where I was working, the snowfall was measured using a table. We would measure the depth of snow, but it would actually be corrected using a table matching temperature to snow amount. And that is not good. So even within the National Weather Service, there were differences. Back before things sort of got settled, co-op observers would measure once per day, and that is the preferred measurement protocol right now. The first order stations and aviation stations would measure every 6 hours, measure new snowfall every 6 hours. And we'll talk about why that's a problem. Snow melting as it falls, which co-op observers are instructed to enter that as a trace of snow. So if it snows all day, like it did around here day after Thanksgiving where I live, most of it melted as it fell. If we would have kept it all as snow, it probably would have been an inch or so, but it didn't. So we enter a trace for the snowfall for that day. First order stations in aviation actually did some estimating of snowfall, assuming that none of it melted, and they would do that using this table. And I'm going to show this table, and you're not going to be able to read much of it because deliberately we don't want anybody using this. There was this melted water to snowfall conversion chart. And for grins and chuckles, you could use it just, looking out your window if you wanted to, but we don't want to use this for ever measuring new snowfall depth. There's a lot of things that go into what constitutes the snow to liquid ratio, and it's not surface temperature. In fact, it's probably one of the least least of the factors that go into it. So other impacts on snow measurements throughout the years has been National Weather Service modernization. The implementation of ASOS back in the mid-90s actually resulted in a significant loss of snowfall observations for a period of anywhere from 1 to 3 years at first order stations at some airports until manual observations could be restored or made at alternate sites. When I was putting together helping develop the accumulated winter season severity index, we used long-term snowfall, temperature, and snow depth records to compute the index. There were several locations that lost snowfall observations, never to get them back. There were a number of locations, for example, Chicago O'Hare Airport had a 2 or 3 year gap where there were no snowfall or snow depth observations. And Boston's Logan Airport to this day is, to the day last year that I last checked, they do not have anybody making snowfall observations at the airport. I believe they might use a nearby co-op station. But so a lot of that was lost with modernization, because the whole idea was to get a package of instruments out there that could measure everything, and they wouldn't have to employ weather observers to actually go out and do this. Over the years, as you might imagine, there's been a decline in the number of cooperative observers as they age out of the system or retire. Then there's also, on the positive side, the growth of CoCoRaHS. We now have about 25,000 volunteer observers in our on record. Not all of them measure snow, of course, but a lot of them do, and we fill a lot of gaps where there were previously no observations. And if you're trying to construct a climatology of snowfall in an area or the U.S., that's very valuable data, especially the longer term stations. One of the big things that I don't think anybody really realized, and I didn't myself for a while, that one of the biggest influences on how we now measure snow was this booklet. And I'm holding it in my hand right now, which I got way back when it was released. It's the Snow Booklet, and this was written by Nolan Duskin and a gentleman named Arthur Judson. Together they wrote this book, and it describes it's an excellent, and it's not a big, the book itself is only about 1/4 of an inch thick, but it has loads of information. It was published in 1996, and it's only 84 pages. It touched on just about every aspect of snow, the science of snow, the climatology of the snow in the United States. But more importantly, it called attention to the problems of and challenges measuring snow and the procedures for measuring snow. And what happened in later on, the National Weather Service established snow guidelines in 1997. After this book came out, this followed a conference in 1996 co-sponsored by the National Weather Service at Colorado State University, where Nolan was based and where CoCoRaHS is based. And after input from many climatologists, snow specialists, observers, data users, the snow measurement guidelines were published, or really established and published at that time. A lot of the content was extracted from this snow booklet that Nolan had written. Those guidelines exist. They were updated in 2013. CoCoRaHS was on the team that helped update those guidelines, and basically National Weather Service guidelines are CoCoRaHS guidelines. So there are minor differences, which I'll talk about later, but mostly those are on the CoCoRaHS side. So you're looking at, basically, it was the mid-90s before the meteorological community, climatological community got their act together on measuring snow, with everybody doing it, or supposed to be doing it, the same. And, you know, here and there, you'll still find observers who haul out either using the 10-to-1 or using that table or some other magic method to measure snow, but the guidelines are there, and that's what we follow. So snow measurements today are actually more widespread than they used to be. The National Weather Service forecast offices plus the co-op program provide snow observations to help replace some of the missing snow observations at stations that get snow, of course, and no longer had full-time weather observers taking hourly observations. They have what are called snow paid observers, where they pay a stipend to basically an observer, not necessarily a CoCoRaHS observer, but they could be, but somebody that will take snowfall observations during snow events. And then, of course, there's CoCoRaHS with our 25,000 observers. I was it's hard to tally each year how many are actually measuring snow, but usually even in the southern states, when they get snow, we get people that will measure the snow and report it. But we have a very good representation, and you'll be able to, I think I have a map that might show some of that later on. And then one program which is automated and which is a valuable tool out west is the SNOTEL program. And this is run by the USDA's Natural Resources and Conservation Service and covers most of the western US. Automated measurements of snow depth and snow water can be made using the technology we have now. There have been attempts to develop automated snowfall measurements. In fact, I remember one being tested out at the Indianapolis Weather Service office years ago, probably 15, 20 years ago at this point, that they were testing out. But the problem is the economics of deploying these, the scaling to get the right size of a detection area. And three properties of snow have made this challenging. One is that snow melts. It can melt as it falls, or it melts as it sits there on the ground. Snow will settle. If you get a light, fluffy snow with lots of air in between the flakes, eventually over time, and it doesn't have to be a long time, that will actually settle down, and what might be an inch will end up being a half inch. And then snow is easily affected by wind. Some gauges are protected by wind shields, which help mitigate the wind's effects on the gauge catch, but that doesn't help you measure the snow on the ground. And if you've measured snow before and you've been in a big windy storm, you know that some areas will be piled with snow with 2 to 3 feet or more, and other areas will be blown clean. And how do you measure that? And it's hard to measure it manually, and it's even more of a challenge with automated instruments. So we found out that trained observers manually measuring snow and its components are still the most reliable means of measuring snowfall, period. And that's a challenge too, because not everybody understands snow. And some of the fine points of measuring it, and it is a process that is as challenging and at times frustrating. So let's talk a little bit about SNOTEL, the one automated system. It's operated and maintained by the USDA. It began in 1997, and it's part of a much larger snow monitoring program that involves snow courses, which is long paths where they actually measure snow depth, and then aerial surveys made by aircraft. There's about 800 SNOTEL sites in the western US and Alaska. They have a standard configuration suite of a snow pillow, a storage precipitation gauge, and a temperature sensor. So they all collect snow depth, precipitation, soil moisture, soil temperature, solar radiation, wind speed, and humidity. And those are transmitted frequently. It might even be hourly or more hourly or sub-hourly to the NRCS. This is the distribution of stations in the network. This is the most recent map I could find of that. And what you see on the right is a typical station setup with the sensors. The big important, interesting thing is the snow pillow, which more or less weighs the snow as it sits on the pillow. Changes in the weight of the snow is measured by changes in the sensors in the pillow, and they can derive those parameters from it. But this is very important. This kind of density is extremely important in the western US because so many areas, in fact, the entire western US really relies on snowfall for water supply, and they also need for this kind of information for flood forecasting.
And this is Noah. I just wanted to point out, Steve, if you go back to that previous slide, I think it's just a real neat thing that the way that they transmit the data, it is real time. And I believe you're right, it is hourly. But this technology dates back to, I believe, the 1960s, and where they were basically transmitting these data packets off of the ionosphere, where meteorites are basically impacting the Earth. And so as a meteorite strikes the Earth, the dust spreads out, and they're actually sending the data off of the meteorite dust. So really neat technology and really effective for transmitting the type of data that they were doing way back then.
Okay, thanks, Noah. And if you're ever out west, you can easily find, I don't know about easily, but you can find these and you can see what they look like. So automated measurements, again, are typically harder to produce. Whoop, I went back too far. Next. So then we talk about co-op network. And this is the co-op temperature equipment sites, which all measure precipitation as well. Surprisingly, the Weather Service does not have a map of a recent co-op map. This dates back to February of 2009, and I haven't been able to find a more recent one. It's probably just a bit less denser because we have lost co-op sites, but that gives you an idea of how well covered the country is in terms of temperature and precipitation measurements. But out west, you don't have those because you need to have people living where you want that, and not everybody can live in some parts of the U.S. And then we turn to the CoCoRaHS network, and this is just taken as of a couple of days ago. This is our active stations in the U.S. And as you can see there, have really excellent coverage in many areas. Out west, again, because of population, we don't have as many. But all those observations are coming into the National Centers for Environmental Information. CoCoRaHS is the largest source of daily precip observations in the U.S. That are ingested into the National Centers for Environmental Information. Again, not all these observers observe snow, even those in Minnesota or the Dakotas or any of the snowier spots. Observers do this if they feel they're up to it and want to do it. So, do we measure snow differently between the Weather Service and CoCoRaHS? Not really. We both measure the actual melted precipitation, the liquid equivalent of precipitation. That's snow, rain, sleet, whatever falls in the gauge we measure. Both programs measure our snowfall, 24-hour snowfall to the nearest 1/10 of an inch. The Weather Service does not have a separate snowfall, snow water equivalent measurement as part of their protocol. We do have an optional one, and we'll talk more about that later on, which we measure to the nearest 1/100th of an inch. And we measure, Weather Service measures total snow on the ground, or what we call snowpack, to the nearest inch. But way back at the beginning of the CoCoRaHS, we decided that we would try and measure snowpack to the nearest 1/2 inch. So you will see a difference there. And then we measure snowpacks. We, as encouraged, once a week in CoCoRaHS. All our data is ingested by the National Operational No Risk Research, can't remember the whole acronym, but up in Chanhassen, who monitors snowpack and snow water equivalent throughout the United States. CoCoRaHS data last year comprised about 75% of the snow water equivalent data that they use. They get other data from satellite information and aerial surveys. So a lot of good information coming in from a lot of programs. While there's some minor differences in parameters and reporting, we follow these guidelines. These were published again in September of 2013. They're available online. If you Google it, you'll get the PDF document, but those contain the guidelines, including some diagrams that you'll see common to not just CoCoRaHS, but to the National Weather Service. So you want to measure snow. That's why you're here, or at least to learn about it. Well, someone once said, he used to love snow as much as me, and then he became a weather observer. And if you've done this at all for a winter, you'll understand what that means. So at this point, I'm going to talk about some equipment that you need, and then we'll turn it over to Noah, who'll talk about how to use that equipment. You'll need several things for snow measurements. You're going to need a rain gauge. A 4-inch rain gauge is ideal. It's easy to handle. We have two that we use within CoCoRaHS, the 4-inch Stratus gauge, which you see there on the right, and a new Tropo gauge, which became available this summer on the left. And also the 8-inch standard rain gauge, the typical co-op gauge, is also acceptable, obviously, for precipitation measurements. So you need this. If you're going to be measuring snow, a 4-inch gauge is much easier to handle and much easier to deal with than an 8-inch standard rain gauge, which has a very tall, heavy can and is harder to handle. You'll need a snowboard of some sort, something to put on the ground that you can measure snow off of. And you'll see this, it can be a sheet PVC, it can be a 1/2-inch or 3/4-inch piece of exterior plywood or a similar material. It should be white on both sides and the edges if it's going to be painted. If it's not painted, it should be white. Anyway, I've heard of some people finding some of these new acrylic cutting boards that are a larger enough size that you can use as a snowboard. You might be able to find those at Walmart or any of the stores like that, and you could use that. It just needs to be flat and it needs to be able to stay in place. And actually, close to the ground, they usually don't blow away. The snow will blow off of them, but the snow won't blow away. You need to be sure you mark that with a flag or a reflector like this, because why? On the left, you see the snowboard with a little bit of snow on it, a little bit of snow on the grass. On the right, another 1/2 inch from now, you wouldn't be able to find that snowboard without something marking it. Should also have a ruler or yardstick to measure the depth of new snow and the total snow. There are special rulers or snow sticks available, graduated in tenths of an inch. That's what we're showing here in the images. Weatheryourway.com carries those. I know at one point they were out of them, but those are very handy. Weather Service has some too, but they don't just give those out. This one you should be able to purchase at some point. Or you can use a regular yardstick or ruler. You just have to convert from tenths or eighths to tenths. So let's talk about winter precipitation types. Snow are small white crystals that are formed when supercooled water droplets freeze in what we call the dendritic zone up in the cloud. Snow crystals can have different shapes, and that's dictated by the temperature at which they form. Snow pellets, or what we can call graupel, are white opaque ice particles, usually round. They form when supercooled water collects on ice crystals or snowflakes. And the thing about this, they remind you of little plastic beads. They typically bounce when they hit a hard surface. They're very fragile. They'll fall apart easily. You can crumble them in your hand. But those are snow pellets or graupel. Snow grains are very small, white, opaque particles of ice. You typically see these in low cloud, drizzly situations where it's very cold. I like to call them snizzle because they're sort of the solid equivalent of drizzle. And you'll see those once in a while. Usually if it's very cold, it has to be pretty cold for these to occur. And then ice pellets or sleet is something we all probably have seen. This is caused by raindrops actually freezing or refreezing before they hit the ground. And they melt. Snowflakes will melt, pass through a freezing layer, and those will refreeze and hit the ground as ice pellets. This typically is a transition precipitation. You'll see this as rain as precipitation during a storm, transitions from rain to ice pellets to snow, or snow to ice pellets back to rain, depending on where you are. The important thing to know is that for measurement purposes, these are all treated as snow. If you see all 4 of these during a storm, there's no reason to go out and try and determine which was which. It might be interesting, but they're all considered frozen precipitation and treated as snow. Freezing rain, our special friend, the bane of most winter weather, that occurs when supercooled droplets fall through a layer of cold air near the surface and then freeze on impact with roads, power lines, sidewalks, everything that's below freezing. This is treated as liquid precipitation because it falls as liquid. It doesn't become ice until it actually contacts the surface or something on the ground. So if we have a storm with the mix, you treat freezing rain differently than you do snow. And then finally, I'll talk about our snow measurement terminology. And in CoCoRaHS, we decided a couple of years ago, we really need to make this explicit so observers understand the difference between parameters. Also to make it easy to talk about. So gauge catch is the amount of water in your rain gauge measured after it's melted. Okay, very simple. It's whatever falls in the rain gauge. If it's frozen, you need to melt it. If it's slush, you need to melt it. But that's your gauge catch. Your 24-hour snowfall is the maximum depth of new snow in the past 24 hours, ideally since your last observation. Your 24-hour snow water equivalent is the amount of water measured from melting a core of snow obtained from the snow on the ground at the depth of the 24-hour snowfall. We'll go into more detail on that later on. And then finally, snowpack depth is the total depth of new snow and old snow and ice at observation time. And this is something we would measure every day. And we talked about snowpack SWE earlier. That's the amount of water measured from melting a core of snow obtained from a location that is equal to the snowpack depth. So if you determine that there's generally a foot of snow on the ground, you take a core from where that snow is 1 foot, you melt it, and that's your snowpack SWE. Details to follow. So with that, I'm going to turn it over to Noah. We'll take it from here. Just let me know when you're ready, Noah.
Sure, I'm taking over here. I will start sharing my screen and starting the slideshow. Are you seeing the proper slide yet?
You're just going to have to change your display setting. There you
There
go.
we go.
Yep, to swap the view. There you go. We see it, Noah.
Looks great. Thank you so much. So yes, I'm going to for all those measurements that Steve talked about. And it seems like it feels like it's a lot, and there's 3 or 4 or 5 different things going on here. But really what we want to keep in mind is that it is basically 3 primary things. It's the snow that falls in your gauge, it's the new snow that falls on the ground, and then it's the total amount of snow that is existing on the ground at the time of your observation. So we'll go over all those things here in a little bit more detail. So I've got my cats love to join me as soon as I start talking. So they're part of the show here as well. We're going over your daily precipitation, and we've already talked about the equipment going on here, and you can see on the screen your daily precipitation. We're talking about gauge catch, and holding up the gauge here in the wintertime, assuming you've got this 4-inch plastic gauge, you remove the funnel in the inner tube and you let the snow fall into your outer cylinder. And so the real thing that you need to do here now is you need to bring this inside, melt the snow that fell in the gauge, and measure it in your inner tube. Now, you'd be potentially waiting all day long to get that snow in your gauge to melt. So the short trick is to use your already calibrated, pre-calibrated inner tube here and go to the sink and add a amount of hot water. Whatever amount of hot water you add, you just need to remember it. You add 55 hundredths of hot water to your snow-filled gauge. You swish it around, and now after doing your measurement, you have to subtract that hot water that you added. So that's the short way to do it. And this is your gauge catch, and this is the primary measurement for CoCoRaHS. Now, 24-hour snowfall. We've already talked about the definitions a little bit, and I'm going to get into a little bit more detail. 24-hour snowfall is the maximum accumulation of new snow and ice in the past 24 hours prior to melting or settling. It's the maximum amount. So when do you measure it? Well, when it reached its maximum amount. And so as soon as the snow stops falling from the storm that you're experiencing, that's the time to go out and take your measurement before any settling or melting occurs. So this is not typically at your time of observation. If you're doing a 24-hour measurement, 7 a.m. every morning, the snow fell throughout the day and ended at 4 p.m. That's the time that you want to go take the observation. Now, you're not going to report it at that time. You're going to wait till your time of observation the next morning. But the goal is to measure every time that the snowstorm stops. And so here's a graphical representation of what we're talking about here. It's 7 a.m. and the snow starts to fall. And look at this. You've got 2.4 inches of snow after it ends. But it's, it still isn't even noon yet. And so you run out and you do a measurement 2.4 inches. Now the sun comes out, and sure enough, it kind of settles, it melts. And if you went out the next morning and did a measurement, you'd find 1.2 inches. And so the correct thing to measure, the correct amount to report would be, again, the maximum amount before any settling occurred. So 2.4 inches would be the amount that you report on your form at your time of observation. So, of course, you might get a second storm throughout the day, and so the key here is when you go out to do that measurement in the middle of the day after the snow fell, the real key here is that you're not clearing your snowboard. You only do that at your time of observation. And so in this case, it snowed 2.4 inches, and you went out and measured it at 1 p.m. And then nothing happened throughout the day, but later in the day, another snowstorm occurred. And now you go out and measure, and you've got a total of 3.6 inches. And then some melting occurs throughout the night, or some settling. Then the next morning, what are you going to measure? The maximum amount that you received prior to any sort of settling or melting. So 3.6 inches would be your correct amount to report for this scenario here. So we've talked about when to go out and do your measurement, but where do you take your snowfall measurement? Of course, separately from the gauge catch, you've got what fell in the gauge, but the 24-hour snowfall should be done on a nice level place where drifting or melting has not occurred. And so, like a snowboard, some people say, hey, I've got a picnic table. Can I use that? That's typically raised up off the ground a little bit. It's not ideal. We really want that snowboard to be level with the ground. And so something flat and on the ground is really the most ideal place for that measurement. But you don't want to put your snowboard in a place where you know that it often drifts for whatever reason. So you take your snow stick or your ruler and you put it into it until it reaches the ground. And then we're doing a measurement to the nearest tenth of an inch. And so sometimes it takes a couple different measurements. Snow is not totally even, as we've all seen. And so taking 3 or 4 measurements is not a bad idea. It's also not a bad idea to get your eyeballs level with that ruler. Get yourself down in there, get on your knees, and put your eyes level with that ruler so you can see it well. And now, at your time of observation, if you're using a snowboard, you would sweep it clean from this point forward. And so here's a great example of replacing the board. You want to put it back onto the current snow level. You don't want to put it into any sort of divots or where you've been walking. You can see that Nolan here, or the founder of CoCoRaHS in this photo, is gently placing it not back in the hole where he's currently standing. And that's the idea. You want to put it flat on the surface. So measuring snow during the snowstorm, you can measure snowfall during the snowstorm, especially if it is snowing cats and dogs, and you want the National Weather Service to know that, hey, I've received 2 inches in the last 1 hour or something. Whatever you feel is significant, you can measure that. But the real key here is you write down those measurements and you keep track of it, but you do not clean off your snowboard. Again, the snowboard only gets cleaned off once per day at your normal time of observation, typically that 7 a.m. Observation time for most people. Whatever your observation time, though, stay consistent, and that's the time that you clean off your snowboard. So we've already talked about it, the 10-to-1 myth. Don't use the 10-to-1 ratio. This map is showing the climatology of ratios. And this climatology being long term. And here, where the light blue meets the dark blue, that's where 10-to-1 really exists. But even here, if it snowed at this location any given time, you can't just assume it's going to be 10-to-1 right here. So we can't stress this enough. Stop doing the 10-to-1 myth. It's no good, and tell your friends. So now we're going to talk about measuring the 24-hour snow water equivalent, which again is separate from this 24-hour snow that falls in your gauge. What we're going to be talking about here is doing a core sample off of that snowboard. So again, the 24-hour snowfall SWE is a distinct and separate measurement. It's going to be different than the liquid that fell in your gauge, and that's for many, many reasons. It could rain first and then it starts snowing. You're going to have something different in your gauge. There's lots of reasons why the amounts can be different, and so we want to make sure that people are doing the two different measurements here. It's optional. You don't have to do it if you're a member of CoCoRaHS. This is something that we're not making our volunteers do. All we really want them to do, the only requirement is that liquid amount that falls in the gauge. But if you are inclined, then we would love you to do a snow core from your snowboard. And it's the melted amount that your gauge catches, including all precipitation, liquid and frozen. The snowfall SWE includes only that part of your total precipitation that was snow or sleet. So basically, this is explaining the difference here. That the melted amount in your gauge is going to be different than the melted amount that landed on the ground. And that's the real key to keep in mind here. And that's why these are two separate measurements. So it's not the amount that melted in your gauge, even if all the precipitation was snow. Two separate measurements. So when do we do this measurement? Again, the ideal time to take that measurement would be at that time when the snow reaches its maximum amount and doesn't settle or melt. And so in theory, you could be doing that snow core from your snowboard in the middle of the day when that snowstorm stops. The key here, though, is that you wouldn't clear that snowboard just in case maybe later on it starts snowing again. So keep some room for more snowfall to accumulate. If one waits until the observation time, a number of things may happen. It could rain and the snow on your board could melt. It could get windy and the snow that fell on your board blows away. And of course, the thing that occurs most in my house, the animals, dogs go out and do what they do, and they might end up walking all over your snow measuring platform. So make sure to ideally do that measurement of your snow depth and do a core sample at that same time off of that snowboard. So here's an example. We're going to show what we're going to do here. You use a snowboard or your other hard surface. You take the core after you have measured the snow depth, but before you have cleared the board. So, for example, if you determine the depth of the new snow is 4 inches, you take your snow core sample from the area of your board where it's 4 inches. So again, if you took several measurements even on your snow board and you had different amounts, try to take your core where you had that average amount. There's no need to take a core of new snow when there's only a trace of snow. So if it's just a trace is a trace. and you got a trace of snow, and therefore the liquid amount is also a trace. So here's the photo of it. You take your rain gauge, you stick it upside down, you stick it down into the snowboard. We say you're cutting a biscuit. And in this example, what I like to use is a spatula, just for flipping pancakes. But here you slide it under your gauge, and now you can flip the cylinder around, and you bring the snow core in, and you do your melting and measuring procedure. And here we are. You add a pre-measured amount of hot water, you melt it all down, you measure it, and then you subtract your amount of hot water that you added. Measuring snowpack depth. So we've talked about new snowfall. The new snow that lands in your gauge is gauge catch. The new snow that lands on the snowfall that lands on your board, and the equivalent, the snow water equivalent, the gauge core sample of that snowboard. But now we're going to shift and talking about total snow depth, snowpack, as we like to call it. So this is the accumulation of snow throughout the season that we're tracking here. And again, this is optional, but it's really helpful to be able to report what is still on the ground throughout the season. So to measure snowpack depth, now we're getting into tricky business here. It's a great example in this photo, but we have all seen it. Snowpack is rarely uniform in coverage. Its character changes, it settles, it compacts, it does weird melting. You name it, there's any number of things that can make your measurement difficult when it comes to measuring snowpack. So oftentimes what you need to do is just kind of take a step back and look over your entire area, not just where your gauge is, not just where your snowboard is, but really your entire scene, if you will. Maybe if it's just your backyard, that's okay, but take a good look at your overall scene and figure out where you feel is the representative of what's on the ground. And it's going to take multiple measurements. We encourage you to go around your area and stick the ruler into different areas and measure at different points in your grass. So as I said, take several measurements. Write them down. Look at this notepad. Look at all those measurements. Add them all up, divide by the number you took, average them out. You want to slide the snow stick through all the layers of snow, new and old. That can get tricky at times, depending on where you live. You can get different layers, and some of it gets really icy and hard to stick that ruler through. So make sure that you're getting all the way through. And here, because it's obviously the way snow melts and is so non-uniform when it comes to snowpack, we're not trying to get to the nearest 1/10 of an inch here or anything. We go to the nearest 1/2 of an inch. And the National Weather Service, as Steve already mentioned, even they go to the nearest whole inch. So there's a slight difference between CoCoRaHS and National Weather Service guidelines, where the National Weather Service says you can average to the whole inch, but CoCoRaHS, we say you can go to the nearest 1/2 inch if you're feeling confident on your values. You don't want to measure artificial accumulations, so don't be measuring where you shoveled and then piled your snow next to your sidewalk. You want to get into a place that has not been artificially set up, and so you also don't want to just measure something that is just consistently in the shade and never sees any sun, perhaps, either. You want to pick an area that is representative of the general day, where it can see some sun, but also might see some shadows. That might be a consideration for where you're taking your measurement as well. Average them all up, and you get your snowpack depth. So here's an example where it really gets tricky. Some days, 1/2 of my grass is covered, the other 1/2 is not. and you end up having to try to do a little bit of a calculation to figure out how much you've got. If half of your grass has an inch and the other half is bare, you could say that you have a half of an inch. Here's an example of 60% of the ground has 2 inches and the rest is bare. Well, 2 inches times 0.6, 1.2 inches, and then you round it down to 1. There you go. So it's slightly subjective at times when you're looking and you're trying to figure out, oh, is that 50%, 60%? Oftentimes what we say in CoCoRaHS, our slogan is do your best. You're doing your best. That's all we can ask. Don't beat yourself up over if you're guessing 40% and it should have been 50% or something like that. So this is something that I like to really point out, especially at the very beginning of your snow season. The first couple of times that it snows, you might still have some grass that actually exists on your lawn. And so you need to be careful, because as the snow falls, it can actually start to settle higher up than really the bottom of the ground. And so if you stuck your ruler all the way down, you might artificially think that you've got deeper snow than if you really accurately put the bottom of the ruler where the snow starts to accumulate. So again, this is especially true early on in the season, but it's something to be careful on as to how you're measuring the depth of your snowpack when you're doing this measurement. Okay, so now the water equivalent of the snowpack. Again, we're going to get a core sample of that snowpack that you just measured. And this is super important to the hydrological community and the river forecasters who really want to know how much water is still on the ground waiting to melt, waiting to go into our rivers and reservoirs and feed our crops for the next season. So doing this measurement provides a nice estimate on what's really on the ground, as I just said. So it doesn't have to be done every day. And, you know, you could if you've got a big enough area. But if you think about it, if you're trying to take a core sample of your snowpack every single day around what might be not the largest of yards, you're going to end up with holes everywhere and no place to measure. So really, if you want to do this just once a week, that is something that is super valuable. And we have worked closely with our partners at the National Weather Service, who have determined that it's most valuable to do that measurement either over the weekend or on Monday, where you report your total snowpack SWE on Monday morning, and we call it SWE Mondays. So again, that's when it's you can do it any day, but it's potentially a little bit more valuable if you did it on Monday as well. So as we already demonstrated with the core sample of the new snowfall on your snowboard, this is getting a core sample of your snowpack based on your representative depth. And so again, if you've taken several measurements around your yard, you want to take your core sample at the location where you've determined that average to be. So again, if you've got 3 inches on one half of the yard and 1 inch on the other, find a place where you've got 2 inches and take a core sample there. And that's the goal. Okay, we're winding down here. So I'm gonna not get into details on these special situations, other than to say that we will provide this PowerPoint to all attendees where you can get into these details. And we've also, I think, provided a link to some of our training materials for CoCoRaHS, which gets into these details. But some very quick basics. What if the snow melts as it falls and never accumulates? We call it a trace. That's the most important thing to remember when that happens. You can still measure the amount of precipitation that landed in your gauge, but for snowfall, if you witnessed a snowflake, it is considered a trace of snow. even if it never even landed in your gauge or melted the very second it landed on the ground. We call it a trace. If there's a mix, there's all sorts of cases where we end up with mixed events, and I'm flying through these slides because all I can say is that, well, the easy thing to say, it's complicated, right? So some miscellaneous things. If it's less than a tenth of an inch, we report a trace. Again, that's kind of reiterating here, but I will get to the very end because I want to take a few questions. So the final thing I want to say, and I just want to mention too, it makes it so much easier to do a weighing of your measurement. So instead of melting and adding water, I would highly encourage you to look into the instructions for for weighing your report or your measurement and reporting it that way. Anyone who converts to weighing very rarely ever goes back to the old-fashioned way. So we've got training resources, and we'll have links to that, and we will end with saying that measuring precipitation accurately has plagued humankind since the dawn of time. And with that, I thank you, and I know we're short on time to reach for the top of the hour, but maybe we have a moment for one or two questions.
Yes, we can take a couple of questions. So just to remind everyone, if you do have any questions that you would like to ask Noah and Steve about their presentation today, Measuring Snow, please go ahead and put them in the Q&A box. I have linked a couple additional resources that in the chat for everyone. We'll have those available. We'll work with Gideon to make sure that we can get those out on the forums as well. There's a YouTube playlist of snow training videos that CoCoRaHS has done that's available. There's a link there. And then there's also a PDF with a little bit more comprehensive training that the CoCoRaHS observers can actually go through, or even just observers in general. And let me see, I've got some question. So Jonathan is asking if we could go over real quick about how to take that core again for the snow. So if either Noah or Steve, if one of you want to just kind of go over that again, that would probably help Jonathan out.
Take it, Noah.
Sure. Yeah. And so just to make it simplified, if we're just talking about the new snowfall that is on your snowboard, you take your gauge, empty of the inner tube and funnel, and you stick it upside down onto your snowboard, onto the flat surface, and it just goes right in there. And I'm spinning my gauge here. In perfect conditions, some people might be able to actually pull that core out, but the real thing to do is slide like a fly swatter or a spatula underneath, and then flip it over, and now you've got the core sample of what was on your board. So it's basically taking a core sample of the shape of your gauge, and then of course you bring it inside and melt it and measure it. I hope that is a good example, and my visual hopefully helped as well.
So Jonathan did say thank you, so that probably helped. Here's another question for you guys. He said yes, it helped. Lloyd says it sounds like there are multiple measurements that are made. If there are multiple measurements made during a multiple snow events in a given 24-hour period, only the highest depth gets reported with the associated SWE at the next report. It sounds like we don't really know if that's the highest until it's actually over it. Now, does that sound correct, or can you guys go maybe a little bit into doing the multiple report? Thanks, Steve.
If you have multiple measurements during a snowstorm, I'm assuming this is continuous. If we have multiple events, that's a little bit of a different issue. Sometimes we don't know when it's over. I can tell you when this whole nice protocol falls apart is if you get a big snow overnight, let's say between 10 p.m. and 4 a.m. Only the most dedicated of snowfall observers might wake up in the middle of the night to go out and measure the snow when it stops. That would be the most accurate. If a particular situation occurs where that snow melts by the next day, we don't we don't have a good snowfall measurement. Yeah, sometimes it's hard to tell when you should go out and do this. If you're getting multiple events, you're not cleaning your snowboard. So you just go out and measure until you think the snow is over. I would like to think most observers are pretty weather-wise. They're paying attention to the forecast. God knows a lot of them are looking at radar either on their computer or on their phone. So usually you have a pretty good idea when the storm is over and when you should go out. So I hope that helps a little bit. But it's not a perfect system, and we're all human and we all need to sleep. And sometimes during snowstorms, some of us don't sleep, but most of us do. And we just do, as Noah said earlier, you do the best you can.
And I'll add that the person that asked that question, they basically had it correct in their mind of what is going on. So that is correct. And I'll finally add that, as Steve mentioned, if you sleep through it, you're not there to see that maximum amount. You can still go out at your time of observation, report what you've got on your board, and we'll take that. That's good. That's a good measurement. So it's only the most dedicated. They're there to catch it at the end of the snowstorm
the real snow weenies. Yeah,
right. That's the optimal time to do it, but you can still do it at your time of observation. And we're certainly not coming after anyone.
I can attest to being the snow weenie that stayed up until 1 o'clock in the morning to get the most accurate snowfall measurement here in South Carolina, because
really, for a South Carolinian, I'm impressed.
Yeah, so
really?
I got two more real. One's a quick comment, the other's another little question, and then we'll close out the webinar. Comment from Ted. He's coming up on 1,000 observations, so congratulations, Ted. And he said weighing is the bomb.
Yeah, all right, nice.
Also said he's found the Facebook CoCoRaHS group has been very helpful and responsive to newbies like me. So while I ask the next question, Noah, can you maybe go get the link to the Facebook page for the CoCoRaHS so that we can share that with anyone who else is interested? And then John wants to know, can you go over the data entry form that we would use? So I don't know if we have the CoCoRaHS. If someone can pull up real quick, maybe what the CoCoRaHS
that
form
probably would be better dealt with separately.
Okay.
It depends on whether you're on the mobile app, unfortunately, or the website. But we have a document we can send John that basically shows you where you enter everything. And I'm more than happy to send that. We send it out to a lot of people, and that'd probably be a help. And again, a reminder that in our regular winter training that we do, that this was based on, we go into how we enter it on our forms, etc. I mean, National Weather Service has different procedures and different things they do, but so we'll be offering another webinar on our winter weather training, the full webinar that we have at some point here in the near future. But if you can email me or Noah or even Melissa, we can get that document to you. That basically is a little cheat sheet that shows you how to enter everything.
Right. I think that takes
care. I just entered the Facebook group page there, which is the group page. We have an official headquarter page, but the group page is, I believe, the one that person was referring to. So that's what I put in the chat here.
Yeah, no, there's a lot of useful information that is shared amongst all of the different observers that are part of there. Dan says he's been observing since 2009. He's still learning, and he thanks us for a great presentation.
Thank you, Dan.
Thanks again for you guys. We appreciate all of the CoCoRaHS observers that were on. If you have not been or signed up yet for a CoCoRaHS to be a CoCoRaHS observer, feel free to reach out to any of us. We'd be more than happy to get you started with the program. We're always looking for people to make those winter weather precipitation reports and our rainfall reports throughout the rest of the year. So with that, Gideon, I'm going to turn it over to you to close us out.
All righty. Well, thank you so much. Thank you. Oh, here I am. Thank you, Steve. Thank you, Noah. And of course, thank you so much, Melissa, for taking the time and, taking a part of your evening to share with us. Very much appreciated. And audience, thank you so much for joining us as well. If you do have anything that you would like to add or to discuss, audience, please feel free to join us at the AMS Weatherband Community Forum. But yeah, with that being said, just a quick note. all weatherband webinars are available at amsweatherband.org. So be sure to check that out because we've got a lot in our library there as well. Thank you everybody for joining us, and we will see you at the next AMS Weatherband webinar. Good night, everybody.